Today we're going to go ahead and find the inverse function with a table, graphically and algebraically. So first we're going to go ahead and we're going to pick some ordered pairs. I like to start with our table of values and then plot those. So as you can see, we'll get really close up here on here. We have the point 0, 1, and we have the point 1, -1, and we have the point 2, 1, 2, -3, okay, and that should be enough. Now, it's really nice when we find the inverse with a table, we simply switch the x and the y. So the 0, 1 becomes 1, 0, and then 1, -1 becomes -1, 1, and the 2, -3 becomes -3, 2. So I always start with the table, and then we can go ahead and plot those points on our graph. So we have the point 1, 0. We have the point -1, 1. And we have the point -3, 2. Am I up at 2 there? There we go. And then we go ahead and connect that line. Now, we're not flipping it or transforming it like we did last class. We're doing the inverse, which is very different. Okay? So there we have our inverse line. Okay, so that's how we do it graphically. Now, algebraically, we take our equation, which is y is equal to -2x plus 1. And once again, we're simply going to swap the placement of our x and our y. So that becomes x is equal to -2y plus 1. And now we're going to solve for y because we want it to be in the form y equals mx plus b. So we're going to go ahead and add 2y to both sides, and that gives us 2y plus x is equal to 1. We're going to subtract x from both sides. Remember, we want that first. So 2y is equal to -x plus 1. And we're going to finish by dividing everything on both sides by 2. Okay, so we have, for our final answer, y is equal to -1/2 x plus 1/2. And that is our equation. And then we're going to go ahead and double check that on Desmos. And so our original equation was y is equal to -2x plus 1. And our inverse equation is y is equal to -1/2 x plus 1/2. And another way for you to check to make sure that you did it correctly is you can convert both of them to tables like that. And as you can see, they are opposites of each other. Our 0, 1 turns into 1. And you can type those in by putting the other ones in the side. Our -3, 2 becomes 2, -3. Okay, let's go ahead and look at our next one here. So once again, we like to pull out those points, or you can make the points using the equation as well. But we have the point 0, 3. We have the point 2, 4. And another good point here is going to be 4, 5. Okay. And so we're going to go ahead and switch those on the table. So 0, 3 becomes 3, 0. 2, 4 becomes 4, 2. And 4, 5 becomes 5, 4. And we're going to go ahead and graph those. So we have 3, 0. We have 4, 2. And we have 5, 4. Okay, and then we're going to go ahead and make that line cover up our entire graph. And now we're going to go ahead and do it algebraically. So we have y is equal to 1/2 x plus 3. We're going to switch our x and our y. So x is equal to 1/2 y plus 3. And now we're going to go ahead and solve. We're going to subtract 1/2 y from both sides. And that gives us X minus 1/2 y is equal to 3. Going to subtract x from both sides. And we have negative 1/2 y is equal to negative x plus 3. And we're going to finish up by multiplying both sides, or everything on both sides of our equation, by the reciprocal of negative 1/2, which is negative 2. So we're going to multiply everything on both sides by that negative 2. And this cancels over here. So we get y is equal to negative 2 times negative x is positive 2x. And negative 2 times positive 3 is negative 6. And we're feeling pretty good about that because we can see from our line here that it does have a y-intercept of negative 6. Let's go ahead and check this last one on Desmos. Once again, our original equation that we looked at for this is y is equal to 1/2 x plus 3. And to find our inverse, we switched our x, y, and solved. So we have y is equal to 2x minus 6. And as you can see, that's what it looks like on our graph. And then we're going to convert both of them to tables and look for those that are opposites of each other. So we have our negative 2 here, so we would look for a negative 2 here. I can type on negative 10 just so they're similar. And as you can see, negative 10, negative 2 turns into negative 2, negative 10. So we have to look for those that are similar in our x and y's. So I'd be looking for these numbers. Here I have my negative 2, 2, and here it would switch to 2, positive 2. And that, ladies and gentlemen, is how to find 3 different ways the inverse function, one using a table, second one using a graph, and the third one algebraically.